Chapter 12, the problem with distant vanishing points. What to do when vanishing points are far off your paper. We've already addressed this issue when talking about two-point perspective and with inclines. What we do is create a grid. And we do this. Take a line, divide it evenly, another line, divide that the same number of spaces, and connect all the dots, and you get a grid that will connect to a vanishing point that's really far away. Now I know we've kind of went through this already. You can take that method and turn it vertically to work with inclines, and in future videos we're going to be using this method in three-point perspective. When finding measuring points, we can't take the distance from the vanishing point to the station point and swing that up to the horizon line like we usually do, because we don't have that vanishing point on our paper. So the alternate method is to do this little technique. You take the distance from the center vision to the station point, swing it over to the line that connects to the right vanishing point in this case, and then a 90-degree angle will get you to the measuring point for that vanishing point that is really far away. The actual position of this measuring point is halfway between these two lines in degrees. You need a protractor for this technique. So I wanted to look at the Brewer method. The Brewer method is popular in drawing things where the vanishing points are far off your paper. Both vanishing points, the left and the right vanishing point. Here's the technique. You draw a vertical line and you divide this evenly. You can use whatever increments you like. So I divided this into 5 even spaces, and you decide on the angle that you want your drawing to be. I'm going to use this. It could be any angle you like. And then over here to the side, you create another vertical line and divide this into the same number that these are. It's going to be a smaller increment. You want these to taper. So I'm just going to make the math easy and use half of what I did. So we got this divided into 5 and this divided into 5. We connect these and you get that grid. Now on the other side, we want to do the same thing. We're creating a grid that goes to the left vanishing point. But the grid on the left side, it has to meet up at that same horizon line. So what we're going to do is take this distance, these increments, and transfer them over to the other side. Now you could use whatever angle you like over here. It won't matter. I'm going to use this. Now I want to take these and transfer them over to the other side. And I'm going to use that same grid on this side, the same distance for each of these increments. The advantage is that you are using your whole paper as your image area. The station point is very far away. We don't even have the horizon line on our drawing. Now we have the problem of how to measure things. We have a grid that we use as a guide to get to our vanishing points. We have the height here. We could say Each one of these is 1 unit. And how do we get depth along the lines that go to the vanishing point? We don't have measuring points on our drawing. And we can't really find them because we don't have our station point, we don't have our vanishing points. Let's back up a little bit and do a drawing that shows where the vanishing points are. Here's horizon line. I'm going to use a compass to find a left vanishing point and a right vanishing point. The station point can be anywhere along this circle. If I do this, station point is there. Center of vision is there. I can take a random point along this circle and draw a line to the left vanishing point and draw a line to the right vanishing point. And this will be a 90-degree corner. In this case, my center of vision is going to be here. So if your station point was here, the angles that are being drawn in perspective are quite different than if the station point was here. So the vanishing points don't move, but the station point is moving. So if we don't know where the station point is, and we don't know where the center of vision is, we don't know what angle these lines coming from these two vanishing points are. That's the case with this. We have no idea where the station point is and no idea where the center of vision is. These angles could be anything. We could just decide on something. I could say that this is 45 degrees in perspective. Now, if this was 45 degrees in perspective, then these two corners are straight across from each other. So I'm just going to guess at a distance here. I'm going to make it smaller than this. And I'm going to say this right there. Let's just say that is 1 unit in perspective. I can't really say that it's not correct because I have no idea where measuring points are. If this was 1 unit in perspective, then here's 1 unit, a true 1 unit, and I connect these two. This will lead me out to the measuring point. And I can't really say that that would be a wrong spot for the measuring point because I have no idea where the measuring point is because this could be anywhere in this drawing. So let's just say, there we go. This is 1. And straight across from that is the other corner. And then we use this grid to guide us to create a square on the ground. Now, if this was not 45 on each side, then it would be a little trickier because then the corners would not line up with each other horizontally. So this is probably the easiest route with this Brewer method. Now we have a square, and we know that these are 45 degrees. So to make a grid of squares, we can take this and just extend it up. Now we have a vertical row of squares. If we want another square here, we can go from corner to corner to create a diagonal, and it hits here and we get another row of squares. So this will also on the ground create a square here. Now you can continue with this. Here's a square on the floor. And here are the vertical squares. So you could continue with this and step and repeat and fill this whole area with a grid that you can use as a helpful tool to measure things. Problem comes in when you want something else in the drawing. Something that's not parallel with this, something that's not 45 degrees to the picture plane, then there's a real issue with getting two other angles that are at a 90-degree corner. Like this we have is 90. And with this little information in the drawing, you can't really say that this is wrong. But if we made two other lines at a different angle than this, then it would be hard to say that they are 90 degrees. So there are some limitations with this. It works if you're just drawing one object. It doesn't work so well if you're drawing a lot of things at different angles. Setting up another grid on top of this one that is at a different angle than this one, where the corners are 90 degrees, then that becomes a little more challenging.